In this video I'm going to take a look at ionic equations, and the reaction I'm going to use for this worked example is the reaction that's on the board now. So that's between aqueous sodium chloride and aqueous silver nitrate to give aqueous sodium nitrate and solid silver chloride. I'm really stressing the state symbols there because, as you'll see, they are key to explaining ionic equations. So I think the best way to explain this is to imagine the beaker before and after the reactions taking place. So on the left hand side we've got our beaker of reactants, so we've got the aqueous sodium chloride and aqueous silver nitrate in this beaker, and as soon as they react together they form an aqueous solution of sodium nitrate and a solid precipitate of silver chloride. Now, if you can imagine zooming in on the beaker, let's have a look at what you would actually see inside. So in the left hand beaker you wouldn't actually see combined sodium chloride, you would actually see the separate ions, because the sodium ion can interact with the water and form a hydrated ion. So you'd actually see the separate ion, sodium and chloride. The silver nitrate does exactly the same thing because it is also a soluble ionic compound, and so you'd see the aqueous silver ion and the aqueous nitrate ion. And then if we think about the beaker once the reaction's taken place, because we've got aqueous sodium nitrate, we're actually going to see the aqueous ions separately, because again this will fully dissociate into the water, and so we see the hydrated ions separately. And we'll also see the precipitate, and notice this is where it sort of changes a little bit. We've now got a solid silver chloride. So why do we see the silver chloride as a single entity and not separate ions? And that's because it's insoluble. How can we tell it's insoluble? That's where the state symbols are really valuable. Because we've got a solid state symbol here, that's telling you that this is insoluble. So we're not going to show the ions because they don't separate out in the water, whereas these all do. So we're now going to treat it a bit like a mathematical equation, and where we see identical terms or ions or species left and right of the arrow, we're going to cancel them out because effectively they haven't changed. So you can see the sodium ion appears left and right, so we're cancelling that. The chloride ion, if we look, it's actually become this solid silver chloride, so we can't cancel that. We haven't got an aqueous chloride ion on this side. Likewise for the silver ion, it's aqueous on this side, but we've got solid silver chloride on that side, so that can't cancel. The nitrate ions can go. So what we're left with after that is what we call the ionic equation. So you can see it's written up here now. And basically the ionic equation, or sometimes known as the net ionic equation, only includes the species or particles that are actually involved in the reaction. In other words, things that have changed. And the ions that don't change, so in this case it was the aqueous sodium ion and the aqueous nitrate ion, we call them spectator ions. So typically what's going to exist as aqueous ions, so we've got soluble ionic compounds, there's a couple of examples there, sodium chloride, potassium nitrate, and also things like strong acids and strong bases, so your hydrochloric acid, sulfuric acid, nitric acid, those sorts of things, and also obviously some alkalis there as well, sodium hydroxide, potassium hydroxide, and so on. And now some examples of chemicals that don't exist as aqueous ions. Insoluble ionic compounds like calcium carbonate, transition metal hydroxide precipitates, and also obviously covalent compounds, things like carbon dioxide. So your turn now. There's 4 examples. See if you can come up with the ionic equations for each one. Pause the video, try them, and then I'll go through the answers. And so there's the answer to the first one. We've got an aqueous hydrogen ion reacting with an aqueous hydroxide ion to form a water molecule. Now, if you have done it like this, where you've got 2's in front of everything, because we've got 2 H pluses, 2 hydroxide ions, 2 waters, what you should appreciate is that these will cancel. So these 2's shouldn't appear in your final answer. There's the answer to the second one. An aqueous iron 3 plus ion combining with 3 aqueous hydroxide ions to form FeOH 3 times solid iron 3 hydroxide. There's the third one. Aqueous barium 2 plus ions combining with aqueous sulfate ions to form solid barium sulfate. And there's the final one. We've got solid calcium carbonate reacting with 2 aqueous H plus ions from the HCl, and that's producing an aqueous calcium 2 plus ion, a water molecule, and carbon dioxide gas.